This video for in 3-3 is brought to you by Lego Batman with his throwing Batman and his scowl face. Oh, but he also has a happy face. No, sort of angry face. Let's do it. So in this section, we're going to buy things on credit or with loans. So really what we're going to do is compute the payments and charges with installment loans and then look at the true cost by calculating the APR, and then look at the cost of buying things with credit. So first to note, what happens is when you are buying things when you don't have the cash and you borrow the money and then you make equal monthly payments over a period of time, that's called installment buying. So there's a whole series of things that goes with this. Usually these are fixed installment loans where you have equal payments over a set amount of time. We typically start with a down payment. It always surprises me how many students get this confused. This is cash that's left your bank account, cash you paid. It decreases the amount of money that you borrow. So here's a couple things that we're going to work with. I'm going to rewrite these a little later. First off, the amount financed is the amount you borrow, and it's simply the price of the item minus your down payment. And then there's going to be the total installment price. I'm going to rearrange this a little bit. What this is, it's the sum of all the payments. So it's this fixed payment. Typically it's monthly. And you multiply by the number of payments you're going to make plus the down payment. Another way to think of this is all the cash you paid. I like to call it total cost. And then the finance charge is the total price you paid minus the price of the item. So this is the extra paid because you didn't have enough cash. So let's run through a little scenario doing these calculations, and then we'll write up some nice little formulas for it using letters. The same letters we used back in 3-1 and 3-2. Okay, so here's a car. Its price is $12,260. Turns out we have $3,000 cash to pay for it. And somehow we got a loan that is going to cost us $231 a month, $231.50 a month, and it's going to take us 48 months to pay for it. So how much is going to be financed? I'm going to call this P as in principal, meaning the amount we're going to borrow. And that's going to be the $12,260. It's the price of the car minus the amount of money we have to pay as the down payment. And this ends up being $9,260. This is the amount of cash we don't have, and it's what we have to borrow from the bank in order for the dealership to give us the car. The next one, what's the total amount of all monthly payments? Well, we're going to pay $231.50 a month. So if I use the unit analysis sort of thing, we're going to do this per month, but we're going to do it for 48 months. Right? So this is the total amount of money we're going to pay over the lifetime of this loan. So let's scamper over to Desmos and let's figure that out. 231.5 times 48. We're going to end up paying $11,112 over the lifetime of this loan. So what's the installment price? Well, I kind of don't like how our author does this. The total installment price, what I like to think about is how much total will we have paid? Well, we're going to have paid this much money plus this much money. So it's the $11,112 we paid for the 48 months plus the $3,000 we paid as a down payment, which equals the $14,112. That's the total amount of money we will have paid to buy this car. So the finance charge, this is how much extra. Like if we had just had the cash, right, we would have paid $12,260 and walked away with the car, the exact value of the car, or at least exactly what the dealership's charging for it. Because we didn't have that cash, we only had $3,000. We borrowed this much, we end up paying this much. How I like to calculate the finance charge is the total of the monthly payments minus the amount we borrowed. How I like to do this is I call this F, and I do the monthly payments M times the number of payments N minus what we borrowed P. That's how I like to write that out. And I'm going to scamper over to Desmos to calculate that. I'm going to show you that there's another way the author asks us to calculate this in a second. So we ended up paying $1,852 extra. Unfortunate, right? I wouldn't mind having this much extra dollars in my bank account. I could buy a lot of Lego with that. Although there's several minifigures that are worth more than this amount. So I couldn't even buy like Mr. Gold minifigure. You couldn't buy it for that much. That minifigure sells for $10,000. The other way that the author has us do it is the author has us take it this amount, the $14,112 minus the price of the car, $12,260. It ends up being the exact same amount. The difference is this has both of the down payments. So this has the $3,000 in it, and this has the $3,000 in it. I prefer this one because it just looks at what did we pay for the monthly payments and what did we borrow as our difference. Okay, so the next big thing that we want to get to then is, well, how did we get to that monthly payment of $231.50? Well, here it is. It's just a big old nasty formula. And by the end of this unit, you will have this memorized. You don't need to have it memorized because you're going to have this on your reference sheet. So note, we call M the monthly payment. It's equal to the amount you borrowed times the interest rate cut into its 12 equal parts, because it's a monthly interest rate, and then 1 minus this 1 plus the interest rate divided by 12 raised to the negative n. You'll see why I used n before with the finance charge. N is the total number of payments, which if we're doing a monthly payment amount, that's going to correspond to the number of months. So let's try out number 5. Here in number 5, we're buying a Honda CR-V. It has an APR of 2.9%, so our interest rate is 0.029. And it's going to be a 60-month loan. By the way, notice that that's a 5-year loan. The sale price is $27,295, but notice we have a down payment of $4,500, and this is the part that most students mix up. We are not going to borrow $27,295 because we're paying this much in cash in order to get a loan to borrow the difference between those two. So in other words, the principal is the $27,295 minus $4,500. And really, those three things is all we need, because then we're just going to plug this thing into our monthly payment calculator, or our formula, excuse me, and away we go. So let's scamper over to Desmos, and we'll type this all in and see what is the monthly payments going to be on this amount that we're borrowing. Okay, so one thing we could do is calculate how much do we need to borrow. I think that's worth noting. It's $22,795. And then we could just start typing it out. Now, I like putting the division sign in first so I can get that fraction. And then I'll type in the $22,795 times my interest rate, 0.029. That's an amazing interest rate. Doesn't exist right now, right? Because interest rates are pretty high. And then this 1 minus 1 plus 0.029 divided by 12. And then all that raised to the, and here's a part that a lot of students mess up. They forget to put this negative in here. And it's a negative 60 because this is a 60-month loan. Notice that we're doing $408.58 per month. That's going to be our monthly payment over a 60-month over the next 60 months. So if we want to know how much are we actually going to pay, this is just extra, by the way, we would take that $408.58 and multiply it by 60, And by the end, we'd pay $24,514.80. That's the total price for the monthly payments. If we subtract the amount we borrowed, there's the extra, $1,719.80. But that's just extra. We weren't actually asked to find that out at this moment. Okay. The next question is an interesting one. I really like it. It says, hey, what if we were doing a simple interest loan? Well, the future value on this would be calculated this way. We'd take the $22,000 and we multiply it times 1 plus 0.029 times 5. If you're wondering where this 5 came from, this is 5 years, because 60 months divided by 12 months per 1 year equals 5 years. So we're going to calculate how much total, what the future value is on this, and then divide that into 60 equal payments and see, well, what would that monthly payment be? Oops, I put 8 years. So if we divide this whole thing by 60, the monthly payments on a simple interest loan, not compound interest loan, would have been $435. Why is it higher? Well, the answer is, with simple interest, the amount of interest you're paying is fixed. So each month you're paying the exact same amount of interest, and you're never decreasing the amount of interest you pay, because the amount of principal you owe doesn't matter. If we go back to here, as we're paying down this principal, this $22,795, the amount of interest we owe on the principal also decreases. So when you're getting a loan, you want it to be a compound interest loan, because over time the amount of interest you have to pay decreases.